Okay, hello everyone. I'm very excited to have the opportunity to present NeuroStride, an AI-driven EEG-based wheelchair. For me and you, doing basic mobility tasks, such as walking, might not be a big deal. But for 25 million people around the globe suffering from quadriplegia, this is a big thing. People suffering from quadriplegia cannot have any voluntary body movements, but they still have an intact cognitive function. What is the problem these people face? Number one, they require constant social dependence. And number two, there's a substantial financial burden, almost $3 million per lifetime. One might be wondering, why don't these people use the current state-of-the-art wheelchairs? The current state-of-the-art wheelchairs, such as the Honda Uni 1 and Omeo, have two fundamental problems. Number one, they're extremely expensive at over 50K USD. And number two, they still do not work for quadriplegic people. They require residual body movements to control, and a quadriplegic person can't even give residual body movements. This is where my solution, NeuroStride, comes in. NeuroStride is an AI-driven, EEG-based wheelchair. My invention, NeuroStride, is a smart wheelchair that is controlled by your thoughts. It is almost 16 times cheaper than the current state of the art. NeuroStride utilizes intelligence from artificial intelligence for motor imagery, or in other words, thinking about motion, to translate intended movements into commands for controlling wheelchairs. Let's take a look in depth at my solution. NeuroStride works in three phases. Phase 1 collects motor imagery data using EEGs and cleans the data using bandpass filters and artificial intelligence artifact removal. Phase 2 predicts the movements imagined using a common spatial patterns, feature extraction, and regression classifier. Phase 3 feeds the predictions to the motor controller that then runs the wheelchair. As we can see in the picture shown on the screen, the way I am reading these brainwaves is via an EEG cap, which has electrodes that are placed on the scalp. What is the accuracy of my system? The accuracy over 200 trials is 91.3%. Its latency is 200 milliseconds, or in other words, faster than a blink of an eye. My
30
system is
seconds.
16 times cheaper, yet it still offers many more features. The next steps for my system are to test with a broader user base, plug and play for portability and usability, and seek partnerships to support clinical deployment. Thanks so much.
Thank you so much. Congratulations for your amazing innovation. Can you
Thanks.
end your sharing, please, so we can see you better?
Can you see me?
Yes. Can you stop sharing now?
Oh, sorry. Give me 1 second.
That's okay. So again, this is a wonderful and really interesting innovation. So we'll have our judges ask you their questions, starting with Katia.
Yes, congratulations. This is amazing. I know this innovation is really useful for many people. My question is about, do you have a personal connection to this project? Like, why this project is important for you?
That's actually a really good question. So I currently live in a condo building that has an elevator, and I have a person in my building who's quadriplegic, and I would see every single time he's coming out of the elevator, there'd be someone pushing him. I would see that he was typically never very happy, and I one day decided to ask him, "Why are you never very happy?" And he told me, I don't have an independent life. I can't go to the washroom by myself. I can't do anything without like a personal support worker having to bring me there. So based on this, I decided to create my solution, NeuroStride.
Amazing. Perfect.
Thanks.
Okay, next, Ade, do you have a question for our young innovator?
Yeah, that's great presentation, Muhammad. I love your energy. I have one question. How the user can control the wheelchair itself?
Hello, we can't hear you. Mohammed, yeah.
Oh, can you hear me?
Yes,
Oh,
now
sorry, I
we
didn't
can.
realize.
Okay.
So that's actually a really good question. And how it works is this user puts on a cap, and the user will imagine moving forward. So it thinks about maybe stepping forward, or stepping backwards, or stepping to the left, or stepping to the right.
Okay, so you put something here and they can imagine.
Yes, exactly.
Okay, thank you. That's great.
Great. Now for our next judge, Brian.
So I saw that you'd created the interface. Well, first off, great invention, and I
Thanks
love
so
what you're
much.
doing again to help people around you. You saw a problem and you're trying to make it better for people. Um, and it looks like you developed a really good tool to read the brain waves to tell it to do something. Um, is there any thought to making that actual interface that goes from your EEG reader to controlling the wheelchair?
Yes, that's actually a really good question. And one of the next steps that we're currently working on is trying to create like a user interface that the user is really like where essentially all the components are in one area, and the only thing they need to do is connect it to the wheelchair. This is something that we're working on as a next step, and what we're currently planning to do is to put all the parts in one 3D printed box and have everything compacted. And I'm currently building a user interface with Python.
Nice, nice, good job.
Thanks so much.
Amazing, Muhammad. Really. The technology behind this is very, very top notch. And I
Uh,
believe that you have the tools now to really make it happen. How about our other students? You still have a minute? Do you have any questions? All right. If we have no more questions, I would just want to again wish you a big congratulations for this innovation. And I hope that we'll see an upgrade or a future go back to gift and share with us what you've done with this. All right.
Thanks so much. And also, if anyone wants to see like a live demo of the wheelchair in action, I'll post a YouTube link on the chat.
That's wonderful. Yes, please
Thanks so
do
much.
so that we could see more of this in action.